guys, this is Mr. Rosario. Welcome back. Today we're going to be looking at interpreting differences in data sets. Last lesson we looked at distribution, we looked at box plots, and we also in 201 discussed the central tendency values. We're going to use those today to be able to interpret differences in center, shape, and spread in a real-world scenario. We're also going to be looking at outliers, which are extreme data points. And we're going to find out how is it that those change your center, your shape, and your spread. If you haven't had a chance to go over 202, it might be a good idea to be able to look at that right now, since it'll give you some of the vocabulary we're going to be using today. Or if you simply need a refresher into what some of the things we'll be discussing today, that would be a good idea. One of the things we discussed in 201 and 202 was not only this idea of distribution, but we said that there are three values we can use to represent the center. So if you have a data set, we can use the mode, the mean, or the median in order to interpret that data. That is the value in the center. Here, in this distribution, the mode would be the highest point. Notice that it is right in the middle where the hump is. That's because if you remember from 201, your dot plots, you'll have more dots here than anywhere else, making it your most often repeated value. So the mode would be right at the center where the peak is located. If you have non-symmetrical values, it'll still be the peak because that is the highest value where most of the observations would be recorded. And if you have what we call right skewed, because you have numbers on the right over here, it'll still be the peak. The mode, no matter what the distribution looks like or the shape is, it'll always be the highest value, the peak. And that would be the number we used for the mode. If we wanted to talk about the data set using the median, well, in a symmetrical data set that we have here, the value would be right in the middle because the left and the right is exactly the same. So when we put them in order, as the median requires, and you have, whether you have one number or two numbers in the middle, it'll be right in between both of these. If you have a non-symmetrical shape, such as this one or this one, what we have is values on the left-hand side. Because we have values on the left-hand side, we call this left skewed, and it pulls your median from the center where it would have been had it been a normal distribution like this one, and it pulls them to those values on the left. If we have a right-tailed or right skewed distribution, we have numbers on the right-hand side, which means the median would be pulled to the right from where it would have been had it been a normal distribution. Now this is a little exaggerated, but it's exaggerated so that you can see it's being pulled. It would not be this much, but just for the effect of what we're trying to discuss here, left values pull the mean and the median to the left. Right values pull the mean and the median to the right. Last lesson we discussed not only will the mean be pulled, but it is what we call the least resistant. It will not resist as well as the median. For that reason, notice the mean is way further away left from where it would have been had it been a normal distribution. That's because the median is more resistant to high values than the mean. So the green is also pulled really far to the right, further than the median when you have right values or right skewed, right-tailed. Notice that if it is symmetrical, the mean is exactly in the middle. In other words, if you get an 80% on a test and you get a 90% on the test, well, when you average those, the average is going to be right in the middle. The median is also going to be here, and the mode is going to be here. For that reason, the mean is the best center value when we're talking about symmetrical. When it is non-symmetrical, since the mean is pulled further away than the median would be the best. And we talked about that last video. If you want to go a little bit more in detail, you can pull 2.02 and that will give you a little bit more details about what that was. We need those in order to discuss the values and how they are affecting the actual information. But before we do that, let's look at a box plot. This is shapes of distributions. What about box plots? Well, in box plots, we talked last video that the median will be right in the middle. And if it is symmetrical, like this one, it looks like the left and the right are the same. We have the same length of the tail. We have the same length on the left and the right of this box. So even though this only gives us the median, because it is fairly symmetrical, the mean is also located there. So if it is exactly symmetrical, even though it's a box plot and we can only tell where the median is, symmetry allows us to conclude that the mean is also there. If it is left skewed, then the left tail would be bigger. If it is right skewed, then the right tail would be bigger. And there is no way to tell where the mean lies. However, I can ask you a question about where are they in relationship to one another. For example, in this bottom one, if I say the median is 32, you can make conclusions about the mean because of this tail being longer on the right-hand side. We just learned that these values pull the median and the mean, but the mean is less resistant, making the mean larger than 32. And that's all we can conclude. Same thing here. The mean is less than the median. And how can I say that? Because the mean is least resistant to values on this case in the left. The smaller values pull the mean further to the left. We don't know exactly where, but we can make those conclusions. So be aware of those types of questions. Now, the other thing we did not discuss on the last video was this idea of vertical box plots and modified box plots. Notice that this is exactly the same as the previous slide. The only difference is that it is vertical. Now, as you go higher, the values increase. That means this number is bigger than this number, because when they go down, they decrease. Modified box plot is a box plot that allows us to know where the outliers are. Outliers are usually denoted by a circle, by an X or an asterisk, and this is the case. These values here represent 3 specific observations which are considered outliers. And an outlier from the last video we learned is an observation that is further away from what we would call normal. There's a mathematical equation for that, but you're not required to know it. All I need you to know is that if you have an asterisk, then these represent observations that are considered out of the norm. For example, if I'm talking about the height of my classmates, and I say the average or the mean, or the median is, 5'3". If a guy walks into my class tomorrow and he is 7 feet 2 inches, he would probably be way out here on the high end, because my median observations are somewhere in this end. And that's what an outlier is. An outlier simply is out of the norm observations. So what kind of effects can they have on your data set? Specifically on the center, on the spread? Well, let's look at this. Here's an example in which Mr. Rosario has 5 basketball games. It says, in Mr. Rosario's first 5 basketball games, he scored 2 points, 23 points, 18 points, 20 points, and 21 points. What would be Mr. Rosario's mean and median points per game, especially if the outliers is removed? Or if the outliers were removed. Sorry about that. First thing we have to do is try to identify any outliers. Well, we notice that we have an observation here of 2 points, and the other ones center pretty close to 20. So what I want to do is, now that I identified my outlier, maybe figure out what the mean and the median would be. So if I have no values removed, remember that we must put them in order. So the 2 goes first, then the 18, the 20, 21, and the 23. And the values in the middle, if I cross out the 2 and the 23, the 18 and the 21 gives me an observation of 20. To find the mean, I have to add them all up and divide by the number of observations, which is 5. So 2 plus 18 plus 20 plus 21 plus 23, which is 84, is going to divide it by 5. And if I do 84 divided by 5, my average points per game, according to my first 5 games, is 16.8. Notice a few things, that the mean and the median are not that close to each other. Notice that the mean is being pulled further away to the lower values. It is closer to 0 than this one is. That means this one is being pulled further away to the left. So if I were to imagine the distribution here, we have something like this, where we have a left tail bigger than the right tail. If we were going to make it a box plot, maybe something like this. And if that's the case, then not only is it left skewed, but because it's not symmetrical, we're going to go with the median. So if we were to say, hey, how many points Mr. Rosario scored, you want to go with the median because this is non-symmetrical. Now let's answer the actual question. What would Mr. Rosario's mean and median points per game be if the outliers were removed? So let's get rid of that 2 and run the numbers again. When we do that, what we have is 18, 20, 21, and 23. So again, the median is the number in the middle. We have 2 numbers in the middle. So we have to do 20 plus 21 divided by 2. That is 41 divided by 2, which gives me 20.5. For the mean, I now do 18 plus 20 plus 21 plus 23, but now I'm doing 4 observations. So rather than dividing by 5, I'm going to divide by 4. That becomes 82 divided by 4, and 82 divided by 4 actually also turns out to be 20.5. Now that the observation that was considered an outlier is removed, notice that my mean and my median are pretty close. Not only close, are exactly the same. So this is symmetrical. Notice that we have from 20 to 23, 2 observations, 18 to 20, 2 observations, and there are 2 observations on the left, 2 observations on the right. So even though this is small amount of points, there's only 4 observations here. If I were to graph it, we would have something symmetrical, where the left and the right are the same. So the shape is the same on the left and on the right. which means that my mean is the best way to represent this data. If we wanted to talk about the spread, then the spread would be, remember, standard deviation. It's not asking for it in this question, but remember that when we do mean and standard deviation go with one another. And we're going to learn a little bit more about that on the next video when we talk about normal distribution. So when I put them side by side, what we have is, with the outlier removed, we have pretty consistent values. In that I can say Mr. Rosario is going to score approximately 20 or 21 points per game. I can't really shoot half a point on basketball, but 20 and 21 is what most of my games were. I maybe had a really bad game. Maybe I was in foul trouble. Maybe I was off. I didn't play enough. Whatever it was, with that outlier, notice that I still am pretty resistant. My median resisted that too. And it stayed pretty close to my actual middle, 20. The mean was pulled closer to that too, because it is not as resistant as the median. So those are the effects of an outlier. When you have a really low value, the mean is pulled to the lower side. When you have a really high value, the mean is pulled to that higher side, and it is pulled further away than the median. When we don't have an outlier, we see that the mean and the median are pretty consistent or close to each other. So that concludes my video here. Hope you had a good time learning all kinds of good stuff about outliers. If you have any further questions or suggestions or anything that I can help you out with, my email address is wrosario@flvs.net. Hope you had a great time. See you next time.